Hello everyone, today we will do the second tutorial focusing primarily on the aerodynamics of the flow around a car. The car speed will be about 200 kilometers per hour or 55 meters per second. The geometry for this tutorial is already pre-made and can be downloaded in the link in the description or on our website. To begin, press the Import Geometry button and select the downloaded car.step file. Here the uploaded geometry is cut in half to make use of the symmetry plane. The first step before simulation is to create a box using two diagonal points. Click the box tool and create the first point at 9.25 for x and 5 for y, and the second point at negative 6.25 for x and 5 for z. With these points, left-click the two dots and you should be able to create a rectangular box. Next, we need to subtract the car from the new volume. Select the subtract tool, the green minus symbol, on the left in Boolean operations and click the box, then hide on the left and press the car. Now we have one body. Let's now move on to naming the surfaces. To name, we will right-click on the front and call it inlet. Similarly, we will right-click on the backside and call it outlet. We'll also call the side of the box with the car symmetry center. For simplicity's sake, we will also name the top and side opposite of the car symmetry. We can do so by holding Ctrl right-click on both. For the remaining floor and car faces, they will all be automatically named walls, so we can just move to pressing to mesh. For the mesh, we will use default cell size with a refinement of 1. We can skip wall treatment and simply press generate. After the mesh is generated, we can check how it looks with a cut line in the X direction using the cut plane tools on the right. There are about 131,000 cells, and the quality is below average, but it's above the red line, so it's still okay. Let's now press to setup. In setup, we do not need to change any fluid or heat model settings. Let's instead start by setting up inlet. Press on inlet in the boundaries on the left side of the program. For the inlet, we will put 55 meters per second in the x velocity and set the length scale to 5 meters. We can now move to the outlet, which we will apply with default settings, and the same can be done to the wall boundary. Likewise, we need to apply symmetry to both symmetries we named earlier by pressing symmetry and then applying and doing the same for the remaining symmetry. For this simulation, we will just use one CPU core, and now we can move on to the solution by pressing to solution. Here, we can create a monitoring point behind the car at 3 for x and 0.5 for y. For this, we can utilize the velocity profile. We can now run the simulation. Now that it's done, we can see it's fully stabilized on a monitoring graph and fully converged on the convergence graph. We can now move on to result. Now we will create a horizontal plane at 0.5 in the y direction. We'll press on it in the boundary section and choose velocity magnitude in the dropdown. We're also able to see the average, minimum, and maximum. The maximum is higher because we are using symmetry, hence why it is accelerating. We can hide the bodies on the right side and hide the plane on the left side. Now, as you can see here, we can look at the contour and bring back the body to continue on with the symmetry. Now we can do velocity magnitude on the symmetry, and since we conveniently named the boundary center symmetry, we can choose that one and just click close and show. So now both velocities are visible on screen, and if you hide the body, you can see them more clearly. For simplicity's sake, let's also align the two graphs by left or right clicking on the graph and setting the maximum to 69. Now on the symmetry center, if we'd like, we can do vector plot by changing the velocity magnitude to just velocity. Now we can hide everything apart from the contour, and we can see there's a recirculation zone behind the car. If you'd like, you can now generate a report, but that will be all for the simple flow around a car tutorial. Thank you for watching, and happy simulating.